class, this is section 10.3, volume for formulas for pyramids and cones. So we have already done surface area of volumes and cones, but this is going to be the volume. It's going to be similar to the formula that you learned for a prism. However, a pyramid is 1/3 the size of a prism. So our formula is going to be a little different. This is conjecture 87, so if you'll put it in your electronic notebook, that would be great. It says, if B is the area of the base, so big B is still the area of the base, you still need to know those formulas. Of the pyramid or cone, and big H is the height of the pyramid or cone, then the formula for the volume is 1/3 times big B times H. So it is very similar to the volume formula for a prism, except for it is 1/3 the size. So we will take 1/3 of big B times big H. Okay, so we're going to do a couple of examples. The first one is going to be harder than what we've done in the past in finding the area of our big B. So this one is a regular hexagonal pyramid. So we have a regular hexagon as our base. As you know, regular means all the sides are equal. The formula for the area of a regular hexagon is 1/2 times the apothem times the perimeter. In this case, we are given that the side of each hexagon is 6. So finding the perimeter is easy. Perimeter is going to be 36. The apothem, however, is not so easy. What we do know is the apothem goes from the center to the midpoint of the side, forming perpendicular lines. So this side right here is 3, and that little piece right there is 3. But we still don't know what the length of the apothem is. If you connect from the apothem or the center to a vertex, you have formed a right triangle. In a regular hexagon, every angle is 120 degrees. You learned that in chapter 5. If I take that 120 degrees and split it in half, making this angle of my right triangle 60, I then have a 30, 60, 90 right triangle. And we learned in chapter 9, if you want to refer back to your notes, that 30, 60, 90 is a special right triangle. We learned that the side across from the 30 is the short side. The side across from the 60 is the short side times square root of 3, and the hypotenuse is 2 times the short side. So in our picture, the side across from the 60 is going to be 3 square root of 3. And that side just happens to be our apothem. So I like this problem because it makes you review your 30, 60, 90 special right triangles. Okay, so the apothem is 3 square root of 3. So I'm going to fill in 3 square root of 3 for my apothem and multiply it by 1/2. Okay, so 1/2 of 36 is 18. 18 times 3 is 54. So our answer will be 54 square root of 3. Now that's just for our big B. We still need to find the volume. So we're going to write down the formula for a volume. 1/3 big B times big H. Big B is 54 square root of 3. Big H was given to be 8. Remember, H is the height of the solid. So 54 divided by 3 is 18. 18 times 8 is 144. So 144 square root of 3 units cubed, so centimeters cubed, is the volume of our prism. Again, that one's a little bit harder because of finding big B in this case. You had to use your special right triangles. If your base is a rectangle, you will use base times height to find big B. So finding big B is the same as you've been doing since the beginning of chapter 8. Okay, so that brings us to a cone. A cone, this cone has a base of radius 3 and a volume of 24 pi. So the volume of a cone is going to be 1/3 big B times big H. They're giving us the volume to be 24 pi. We want to find the height, so we are looking for big H. So 24 pi equals 1/3 times big B. Big B in this case is a circle. To find the area of a circle, you find pi r squared. So in this case, that's 9 pi. And we are going to solve for big H. So 9 divided by 3 is 3 pi. We can divide both sides by 3 pi. To get 8 for the height of our cone. Okay, so for class tomorrow, I'd like you to try these 3 problems. The first one is a rectangular pyramid, so our base is rectangular. The second one is a hexagon, so refer back to the example in the video. And then the last one, you're going to find the volume of a cone and then divide your answer in half. One other thing I'd like to mention are the 5 platonic solids. If you will look in your books on page 544, it describes the 5 platonic solids. There's a paragraph there. I'd like you to read it. You will be given handouts. I'd like you to cut out the 5 platonic solids and put them together. So read page 544 and make the cutouts and make your 5 platonic solids.